हेलो स्टूडेंट्स, गुड इवनिंग। आज मैं लेकर आई हूँ लाइट, रिफ्लेक्शन और रिफ्रैक्शन का लेक्चर नंबर 5, जिसमें हम देखेंगे व्हाट इज रिफ्रैक्शन, द रिफ्रैक्शन थ्रू ग्लास प्रिज्म, नॉट द प्रिज्म, सॉरी, it will be rectangular slab and lenses. What is the lens formula, magnification for the lenses, and at the end we will do some numericals along with how to find out the power of a lens. So let's start करते हैं। वेलकम है आपका अपने चैनल लेट्स गो फुल में। तो सबसे पहले देखते हैं व्हाट इज रिफ्रैक्शन। सो इट appears when light traveling obliquely from one medium to another. Why says it's obliquely? Suppose this is one surface. Here we have one medium, and suppose at the second medium we have glass. So when the light will come perpendicular, there will be no bending of light. That is why it says traveling obliquely. Means its light is coming at some angle with the normal. Normal means perpendicular to the surface, and light is coming with some angle. From one medium to another, the direction of propagation of light in the second medium changes. So instead of following to the same path, either it will bend towards the normal or it will bend away from the normal. Depend what is the density of the second medium. And this phenomena is known as refraction of light. So what is refraction of light? When light traveling from one medium to another medium obliquely, so it changes its path, and that change in path is known as refraction. This happens because there is change in speed of light from one medium to another medium. Suppose this medium speed is v1 and the second medium speed is v2. And because of this, the bending of light happens. Different medium, different speed, so bending happens. In this chapter, we will study the refraction through glass slab and lenses. And next chapter to this, we will study through prism also. Okay, so definition is clear. What is refraction? Okay. So if you understood the definition, see here how the refraction happens through a rectangular glass slab. Here we have a rectangular glass slab whose outer boundary is A, here B, and then C and D. So suppose the outer medium is air, that is medium 1, and the second medium we have glass, and consider that as medium 2. And there is a on surface AB, one normal is there, N dash. This line is normal. So when light are incident in the direction of EF with angle of incident I1. Can you see here I1? So here EF is known as incident ray and we mark it with arrow. EF is incident ray, angle I is incident angle, then N and dash is normal on the surface AB. Then when the light has come, let me mark it with different color. Light has come from medium 1, that is from air to the medium 2. Instead of going in a straight path, it has bent little bit towards normal. When I say towards normal, it means the gap was more. See the dashed line and this. Now this gap is little less. Means it has bent toward the normal. The distance between normal and the refracted ray has reduced. आपको दिख रहा वहां से distance कम हो गई है. So it is bending towards the normal. So जब वो लाइट दूसरे सरफेस पे आई वहां भी मैंने एक नॉर्मल ड्रॉ किया, दैट इज m dash. Let me clear it. If you see m dash is normal on the surface CD. And light जो ये आई at the surface of CD, वहां से again straight ना जाके फिर से bending away from the normal. Straight क्या होता है? It should be something like this. तो straight ना जाके वो bend हो गई which is towards red color. दिस पाथ, तो अवे फ्रॉम नॉर्मल चली गई। क्लियर? सो जब पहले मीडियम से दूसरे मीडियम में आई तो इट हैज बेंड टुवर्ड्स द नॉर्मल, और जब दूसरे मीडियम से वापस पहले मीडियम में गई तो अवे फ्रॉम नॉर्मल चली गई। फ्रॉम 1 to 2 आते समय जितना टुवर्ड्स नॉर्मल बेंडिंग हुआ, डेविएशन सपोज x था, तो 2 से 1 के समय अवे हो गया डेविएशन एंड अगेन x। तो ये अगर मैं पॉजिटिव डेविएशन लूं और इसको नेगेटिव डेविएशन, तो ओवरऑल डेविएशन जो होता है डायरेक्शन के टर्म में वो 0 हो जाता है। एज जितना टुवर्ड्स हो उतना ही अवे हुआ। द लास्ट लाइन जिसको हम बोलेंगे इमर्जेंट रे विच कम्स आउट ऑफ द सेकेंड मीडियम, उसको हम बोलते हैं इमर्जेंट रे। इमर्जेंट रे इंसिडेंट रे के पैरेलल होगा। अगर मैं इनिशियली जो EF इंसिडेंट रे था, if I will compare it with emergent ray and incident ray, they both will be parallel. ठीक है? The long dash line is your incident ray. So they both will be parallel with some gap in between them, and we denote it with small d, and we say it lateral deviation. Lateral deviation through glass slab. ठीक है? So when light enter obliquely, it deviate little bit, and emergent ray is parallel to the incident ray with perpendicular deviation. Perpendicular means दोनों के बीच का distance is d, and we say it lateral. Why lateral? Because it is horizontal deviation. ठीक है? So this is about refraction through a glass prism. इतना clear? Okay. So if I'll tell you the summary, it will be something like there is two kind of medium, rarer and denser. ठीक है? Rarer and denser. When the density is less, we say rarer medium. When density is more, we say it denser medium. Clear? So rarer medium and denser medium. So here air has less density, we say it rarer, and the glass has more density, we say denser medium. I want to make clear over here, like optical density and actual density both are different. So optical density and there is a mass density. They both are different terms. Optical density is related to refraction, and mass density is actually mass upon volume. So maybe some substances which are less density, but it can have more optical density. And the example is kerosene. Kerosene has less density than water. Less density means if you pour kerosene on water, it will float over the water. So it has less density. But if I see the bending of light through the kerosene, it will be more than the water. If I'll allow the water, I will allow the light to pass through air to water, and if I'll allow the light to pass from air to kerosene. So bending will be more in kerosene compared to water. And this is like optical density for kerosene is more than water, which is less denser, less mass density. केरोसिन की जो डेंसिटी होती है वो वाटर से कम होती है, मास डेंसिटी, लेकिन ऑप्टिकल डेंसिटी ज्यादा होती है। क्लियर? ओके। सो अगर यहाँ पे आप देखें, अगर लाइट रेयरर से डेंसर में जा रही है, ठीक है, तो रेयरर में स्पीड ऑफ लाइट हाई होती है, हाई, और डेंसर में स्पीड ऑफ लाइट लो होती है। ठीक है, याद रहेगा। ऐसा समझिए कि रेयरर मीन्स देयर इज अ लेस क्राउडेड। व्हेन इट इज लेस क्राउडेड यू कैन रन फास्टर। सेम वे फॉर द लाइट। जब रेयरर मीडियम है, देयर इज सो मच स्पेस टू मूव, सो लाइट ट्रेवल फास्टर, एंड व्हेन देयर इज डेंसर मीन्स क्राउडेड एरिया, तो आपकी स्पीड कम होगी। सो दैट इज व्हाई इन डेंसर मीडियम द स्पीड रिड्यूसेस। क्लियर? ओके। So when speed is high and when its speed is low. So जब light rarer से denser में जाती है तो towards normal bend होती है, towards normal. When light moves from rarer to denser, it bends towards normal. तो देखिए यहाँ एयर रेयर था, ग्लास डेंसर है, तो जो इंसिडेंट रे आई दैट हैज बेंड टूवर्ड्स द नॉर्मल, शिफ्ट हो गई नॉर्मल की तरफ. सो इट इज बेंडिंग टूवर्ड्स द नॉर्मल. एंड अपोजिट, if denser to rarer it is coming, it will move away the normal. Like here, यहाँ glass which is denser to air. So it's, instead of moving straight, it has moved away from the normal. This much is clear. And why the bending has happened? Because of the speed of light is different in different medium. जो लाइट की स्पीड है वो अलग अलग मीडियम में अलग अलग होती है. वेयर जहां पे स्पीड लेस होगी वो नॉर्मल की तरफ बेंड होगा और जहां स्पीड ज्यादा होगी अवे फ्रॉम द नॉर्मल जाएगा. इतना क्लियर? ओके, तो चलिए फिर नेक्स्ट टॉपिक देख लेते हैं. ओके, so let's learn the laws of refraction. The way we have learned laws of reflection, the same way we have few laws for the refraction. Refraction के laws क्या क्या हैं? First law is the incident ray. I'm sorry. The incident ray, refracted ray, and the normal to the interface of true transparent medium. At the point of incidence, all lie in the same plane. Means, suppose this is rectangular glass slab, this is incident ray, this is normal, and this is point of incidence ray. ठीक है? If I'll mark differently, so the green one is incident ray, this is normal, and this is away from. As it is medium 1, this is medium 2, incident ray, air is rarer, and this is denser. So if this is rarer and denser, when light comes from rarer to denser, instead of going straight, it will bend towards normal. है ना? देखिए नॉर्मल के पास आ गई. So यहाँ पे incident ray, the green color, then refracted ray, let me mark it with this red color, and normal, let me mark it with orange. So this is normal. All these three lines along with the point of incident will be in same plane. Means if you take a rectangular sheet and you keep it straight or bending, you can take all these three lines and incident point on that rectangular sheet. So it means they are on the same plane. So this is the first law. See the second law. Second law says the ratio of sine of angle of incidence. Sine means trigonometric ratio में हमने पढ़ा है perpendicular upon hypotenuse. Correct? So the ratio of sine of angle of incidence to the sine of angle of refraction. अब ये देखते हैं भाई. Incident angle over here I, refracted angle over here R, normal and refracted ray के बीच में. तो अगर आप साइन I लेते हैं इंसिडेंट एंगल का एंड रिफ्रैक्टेड एंगल का साइन का रेशियो, ये हमेशा कांस्टेंट होता है. कांस्टेंट मतलब कि ये लाइट किस कलर के लिए है वो फिक्स्ड होना चाहिए, एंड जो दो मीडियम आपने लिए हैं उनका पेयर फिक्स होना चाहिए. सपोज आपने एयर लिया और ग्लास लिया, तो एयर और ग्लास, आपने व्हाइट लाइट ली तो व्हाइट लाइट, तो आपके लिए एयर एंड ग्लास का साइन आई साइन आर व्हाइट कलर के लिए कांस्टेंट होगा. सपोज आपने येलो कलर ले लिया तो येलो कलर के लिए साइन आई अपॉन साइन आर कांस्टेंट होगा, बट दैट कांस्टेंट विल बी डिफरेंट फ्रॉम दिस कांस्टेंट. इफ यू आर टेकिंग द रेड कलर, अगेन साइन आई अपॉन साइन आर विल बी कांस्टेंट, but that constant will be different from this constant. Clear? And this law is known as Snell's law of refraction. Clear? Okay. And this constant value is known as refractive index. for that particular combination of two medium 1 and medium 2. ठीक है? So that constant is known as refractive index. So let's see what is refractive index now. So there are two types of refractive index. One is relative refractive index, another one is absolute refractive index. So let's understand these two types of refractive index. ठीक है? So refractive index, we know it is nothing but sin I upon sin R. Correct? Okay. So suppose this is first medium and this is second medium. Incident light and this is refracted light. I am assuming density of 2 is greater than density of 1. Okay? Second one is denser medium and the first one is rarer medium. That is why the light is bending towards the normal. This is incident angle and this is refracted angle. Clear? Okay. So if I say refractive index of medium 2 with respect to 1, मतलब सेकेंड मीडियम का रिफ्रैक्टिव इंडेक्स कितना है कंपेयर टू फर्स्ट मीडियम, इसको हम बोलते हैं रिफ्रैक्टिव इंडेक्स ऑफ सेकेंड मीडियम विथ रिस्पेक्ट टू फर्स्ट मीडियम या फिर रिलेटिव रिफ्रैक्टिव इंडेक्स. वाई से रिलेटिव? क्योंकि यहाँ पे हम सेकेंड मीडियम के रिफ्रैक्टिव इंडेक्स को फर्स्ट से कंपेयर कर रहे हैं. वी आर कंपेयरिंग द रिफ्रैक्टिव इंडेक्स ऑफ सेकेंड मीडियम विद द फर्स्ट वन एंड दिस इज sin I upon sin R. क्लियर? इसी को आप डिनोट कर सकते हो. सपोज फर्स्ट मीडियम में लाइट की वेलोसिटी इज v1 एंड इन सेकेंड मीडियम द वेलोसिटी ऑफ लाइट इज v2. सो यू कैन राइट दिस एज v1 upon v2. So second medium का if you want to calculate refractive index, you have to take sine of incident angle, sine of refracted angle, or velocity of light in first medium upon velocity of light in second medium. Suppose you want to do calculation opposite, means refractive index of medium 1 with respect to 2. So you have to write inverse this also, sin R upon sin I is v2 upon v1. So this is about relative refractive index. Refractive index of one medium with respect to or compared to the other medium. So now what is absolute refractive index, which we simply denote N or sometimes like NM, refractive index of a medium. If you take the first medium as air or vacuum, either you take air or vacuum and try to find out the refractive index of some medium. Suppose this is second medium is any of the medium, air, glass, anything. So when we try to find out the refractive index of a medium with respect to air, we say it absolute refractive index. And the same to same, sin I upon sin R is equals to C upon V. C is the speed of light in air or vacuum, which is almost equal. And then V is the velocity of light in the medium of which we are trying to find out the refractive index. Get clear? So relative and absolute, there is one difference. Absolute refractive index we find with respect to air or vacuum, and relative refractive index we find in compared to some another medium. Clear? So let's do some numerical so that you can understand what they are exactly. Okay, so the first question is, suppose this is water and this is air. So speed of light in air is 3 into 10 raised to 8 meter per second. And speed of light in water is 2.25 into 10 raised to 8 meter per second. What is the refractive index of water with respect to air? Means it is nothing but absolute refractive index, because we are comparing it with water. So what is that? We have seen it is nothing but sine I upon sine R. But as angle is not given, we have to take the speed, and which is C by V. Speed of light in air 3 into 10 raised to 8. Speed of light in vacuum 2.25 into 10 raised to 8. Just solve this. So remove the decimal, it will be 300 upon 225, and 10 raised to 8, 10 raised to 8 cancel. If you cut it with 25, it is, okay, let it cut with 5 first. 5 6 are, 5 zeros are, 5 4s are, 5 5s are. Then 15 3s are, 15 4s are. 4 by 5, which is 1.33. So refractive index of water with respect to air is 1.33. Clear? Okay. So let's see the next question. So now let the question is, if air travel from rarer to denser medium and incident angle is 60 degree and refracted angle is 30 degree. And because this is denser medium, so light will bend towards the normal, and that is why angle got reduced. So the question is, find, this is medium 1 and this one medium 2. Find the refractive index of 2 with respect to 1. This is the question. So how to do? This is relative refractive index, the first one, as it is says the medium 2 with respect to medium 1. And as they have not mentioned, medium 1 is air, so we say it refractive index of 1 and 2. So it is relative. So that is nothing but sine I upon sine R. Sine I is 60 degree, so sine 60 degree, and refractive angle is 30 degree, so sine 30 degree. Sine 60 root 3 by 2, and sine 30 1 by 2. So 1 by 2, 1 by 2 cancel, root 3. Root 3 value is 1.732. So the refractive index of medium 2 with respect to medium 1 is 1.732. Now, if I'll ask what is refractive index of 1 with respect to 2, correct? If this is my question, then what to do? Nothing but reverse the formula. This will be sine R upon sine I. So sine R is sine 30 degree. Sine 30 is 1 by 2 and denominator root 3 by 2. Correct? So the answer will be 2 and 2 cancel, 1 by root 3. There is easier method to do this sum is, let me clear some space, then I'll tell you. If we are trying to find out refractive index of medium 2 with respect to 1, which is nothing but sine I upon sine R. And in case I want to find out refractive index of 1 with respect to 2, this is nothing but sine R upon sine I. जहां से लाइट आती है उसको हम पहले लेते हैं. So जब हम सेकेंड मीडियम की मतलब फर्स्ट मीडियम की विथ रिस्पेक्ट टू सेकेंड बात कर रहे हैं, तो दिस इज फर्स्ट मीडियम. यहाँ पे एंगल पहले लेंगे न्यूमरेटर में, पहले इन द सेंस वी हैव टू टेक इन न्यूमरेटर. जस्ट मल्टीप्लाई दीज टू. सो 1 refractive index 2, refractive index of 2 with respect to 1 into refractive index of 1 with respect to 2. अगर इन दोनों को मल्टीप्लाई करें तो क्या होगा? देखिए, sin I upon sin R, let me write it, sin I upon sin R, and second one is sin R upon sin I. Both got cancelled, so the answer is 1. You can take this term in the denominator, so it will be फाइनल कहाँ लिखे हैं? टॉप में लिख देते हैं. रिफ्रैक्टिव इंडेक्स ऑफ 2 with respect to 1 is nothing but 1 upon refractive index of 1 with respect to 2. मैंने the second term I have taken denominator. This term I have taken in denominator. So this is the relation. If you want to find out refractive index of 1 with respect to 2, it will be reverse of refractive index of 2 with respect to 1. Clear? They are inverse of each other. Is this much clear? So let's see the next question. So the next question is, Suppose I have glass slab whose thickness is 10 mm. ठीक है, I have a glass slab whose thickness is 10 mm. And the refractive index of this glass material is 3 by 2. As I say, refractive index of glass is 3 by 2. I am not mentioning any other medium. So definitely it will be with respect to air. It means it is absolute refractive index. Clear? Okay. So my question is, if the thickness of glass slab is 10 mm, refractive index is 3 by 2, which is absolute refractive index, and light is coming. So how much time it will take to pass this thickness or to pass this glass slab? I need time to calculate. Clear? Did you understand the question? Okay, so let's solve it. Refractive index is given, and so absolute refractive index is nothing but speed of light in air upon speed of light in the medium. Refractive index is 3 by 2 and speed of light is 3 into 10 raised to 8. Speed of light in air. Because the first medium is air, so speed of light in air is 3 into 10 raised to 8. Absolute refractive index, that is why I have taken air. If it would have been relative refractive index, so I need to take the speed of light in that particular medium. And V I don't know. Clear? So from here you can calculate V. V is nothing but 3 into 10 raised to 8 upon 3 and into 2. So these got cancelled, and 2 into 10 raised to 8 meter per second is the speed of light in this glass. Clear? But we don't want the speed, we want time. No problem. Speed equals to distance upon time. Correct? Speed is 2 into 10 raised to 8. Here the notation is S, but actually V is speed. Clear? Distance is 10 mm. So D is 10 mm. But speed is in meter per second. So I need to convert mm into meter. So D is 10 mm. Divide it by 10. So you'll get centimeter. And then again, so this is 1 centimeter. Again you divide by 100, you'll get meter. So the distance is 1 upon 100 meter, and there is a time. So time will be nothing but 1 upon 2 into 10 raised to 8 and into 100, which is, let me draw it here. So T is 1 upon 2, which is 0.5, and denominator, can you see? 10 raised to 8 and 100 means 10 raised to 2. So this is total 10. So the answer will be 0.5 into 10 raised to minus 10 seconds. Final answer is time is 0.5 into 10 raised to minus 10 seconds. This is the time required to cross the glass slab by the white light. Is this clear? Okay? Chaliye. So here are few questions for your homework so that you can practice. The first question is, if refractive index of water is 4 by 3 and speed of light in air is 3 into 10 raised to 8 meter per second. There is no unit for the refractive index because it is a ratio of same unit. So there is no unit for the refractive index. Find the speed of light in water. This is the first question. What is the question? Refractive index of water is 4 by 3. Here, speed of light in air is 3 into 10 raised to 8 meter. We have to calculate the speed of light in water. This is your first homework. Practice sums. Instead of say homework, I will say practice sum. Clear? And the second question is, question 2 is refractive index of diamond is 2.57 and refractive index of glass is 1.33. So question is, how fast light travel in glass compared to diamond? Compared to diamond. This is my question. How fast light travel in glass compared to diamond, given that the refractive index of diamond is 2.47 and refractive index of glass is 1.33. So we have covered till here, and the remaining portion we will cover in next lecture. So hope so your doubt got clear for each and every topic which I have explained over here. So in next class, we will cover the refraction through lenses, their ray diagram, lens formula, magnification, and what is the power of the lens. By the time, keep practicing, keep studying. Okay, bye-bye.